Hi, everyone. As soon as you've got a moment or through your pizza coma, we can get started. So this evening is going to be a little, I think the production term is janky, because one of our main boxes that we do all our live streaming and this, and we have it all integrated, well, its internet doesn't work. So we're having to use duct tape and bubble gum to try to put things on the screen and do the live stream at the same time. So we're hoping it's all going to work. So cross all your fingers. Hopefully it will all work. So this evening we've got two presentations, a lightning talk and a full presentation. And the first presentation I'm really looking forward to, because to me, yes, this chapter is part of OWASP and we're under the OWASP umbrella, and it is an international foundation with 130 chapters around the world, and tools and conferences and but to me, it's about what we can do for our community here. How can we help people skill up? How can we make connections? How can we help people find jobs? How can we help people find better jobs? And have pizza at the same time. So what the missions that this chapter I envision having is that we also meet with other groups and learn what they're doing, so we can all help the greater community. So with that, I were through something else. I stumbled through Invest Ottawa. I learned of an organization called the Ada Sisterhood. And when I learned about what they were doing, I thought, well, wouldn't it be great if they came and told us what they're doing, so we can help network and make those connections. So we're very fortunate to have the founder, Kira, speak to us. She's recently graduated from computer programming at Algonquin College, also known as the Gonk, where she founded the Ada Sisterhood. Who knows or doesn't know where the name Ada came from? Correct. So Charles Babbage was trying to create this difference engine as a general computing device, and his, I don't know, am I correct in saying his cohort, his partner, his mentor and guide maybe, was Ada Lovelace. Associate, yes, sorry. It sounds like Walmart. So, she was the first computer programmer. So Kira's going to talk about the Sisterhood, which was a student initiative, and what that small campus club grew into in terms of partnerships and nonprofits, to give individuals, members, leadership opportunities across the Ottawa tech community. So Kira currently serves on the 2026 Board of Directors for JCI Ottawa, and I'm sure you're going to tell us what JCI stands for, as Director of External Relations. So please welcome Kira.
Can you hear me on the live stream? Yeah, okay. Hi guys, thank you so much for having me here today. So I started a club at Algonquin College called the Ada Sisterhood, and I'm just going to quickly kind of go through like why I started it, how I started it, what we did, and kind of like where it's going now. So my first semester at Algonquin College taught me that the job market here is absolutely, I can hear myself, sorry. Is very tough. Like, it's very competitive, it's very tough. And I was really scared. I didn't know how I was going to stand out. So everybody in my program was taking the exact same classes. They could get the exact same grades as me, do the exact same projects. So how was I going to get a job if I was the 10th person in line with the exact same credentials as the previous people? So I asked a professor, I said, should I take the leadership class? Should I volunteer? Like, what are my options? How can I differentiate myself from others? And she said, why don't you start a club here at the college to support women in technology? So she said there had been one, but once you graduate, club leaders can't lead anymore. So she said the club died with that one, and there's space for a club. So then I started the Ada Sisterhood. There was 4 other people with me together in the room when she suggested it. So I came up with a name, the Ada Sisterhood. We had a bunch of awful names like Coding Divas and yeah, just names that were not. So we wanted something that was going to really represent us maturely, not coding queens or divas. We had a logo, and so we were all ready. We booked our classroom, our logo was up, our slide was up on the projector, and one student showed up to our very first meeting. Just one person. There was more leaders than there was members. So we held weekly meetings. So we thought, well, we'll do weekly meetings. We'll have one every week, every 2 weeks, the same room, same location, and maybe we can get some more people to show up. We did a Python workshop. We thought maybe we'll teach Python. Our first thing was to change Celsius into Fahrenheit. Like, we just built a little script to do that. And then I was like, well, maybe I could have a guest, like a guest speaker. And I invited a professor. And no one showed up except the professor. So I couldn't make it. None of my leaders made it. And the professor called me and he's like, hi, is it room C2 or whatever? And I said, yeah, sure is. He goes, well, I'm the only one here. I was like, okay, it's not embarrassing. It's fine. So that's where we started. That's where the club started. My first attempts were not great. So then co-op. I had to apply to get a co-op, and it was extremely rigorous. I had to apply to hundreds of places, and I've seen a lot of my friends really struggle. They were doing everything that you're supposed to do, your cover letter, your resume, reaching out to contacts, and a lot of them still weren't getting a co-op, and some of my really good friends didn't. One of my closest friends did. She's brilliant, and I definitely felt there was one professor, the same one who showed up and no one else did. He said that if you don't get a co-op, you could volunteer for a nonprofit organization. So if it's the summer, you don't have a co-op, why don't you reach out to an organization that you care about and that you're passionate about and ask if you can do a project for them, help them out. A lot of nonprofits need technical help but can't afford it. And I thought I could do that with my club. So instead of applying to do that by myself, I will just gather a bunch of students and we'll do it together. So that was one of our first real wins. We reached out to JCI Ottawa, who is Junior Chamber International. So they have a local chapter here in Ottawa, but they're all over the world. So they have lots of other chapters. They have Canada, and then they go internationally. So I reached out to the current president there and said, can we do a technical project for you? And he said, we need a website. So that's what we did. We built JCI Ottawa a website, and students really liked it. I finally had people signing up. I finally had people in rooms. We were having meetings. We were actually building something. The site is live. People use it. So it went really well. From that, we also got to build Congo Week. So after we built for JCI Ottawa, we did Congo Week, and I learned a really big lesson here that developers are not designers, and designers are not developers. And you really need a good mixture of people on a team to produce something. We had all the code ready to go, but our website looked awful. Like, we just couldn't get the color palette right. We couldn't get things right. So I had to reach out to UX designers and marketers and, get a diverse team. And we also learned that doing one thing is enough. So if you just know how to code the front end, perfect. That's enough. You don't have to know how to code the back end and the front end and design to be a valuable team member. So those are a really good lesson for me and the team there. So I got a co-op at Nokia, and then I applied to become an ambassador at Nokia. And through there, I met Julia, who works with the campus recruitment there. And I got to meet her, and I kind of got to tell her that I run the club, we built some projects, and I said, I think it would be really cool to have an all-women networking event. I don't know how to plan an event, but I think it would be something that I would enjoy doing one day. And Julia said, let's make it happen. She said, we'll do it. We'll do it here in the lobby of Nokia. And you can invite all of your members in. We'll bring in mentors. And so we did. I got to plan the food, the music, the layout, and we got to bring everybody. I had 80 people registered. 50 showed up, which was great because the capacity was only 50. So we had a waiting list of people to get in. They had mentors. We had speeches. It was a great event. It was our first event, and it gave us some credibility. Like, being able to say that we held an event at Nokia kind of made it a little less than we had a professor standing alone in a classroom. So then I went to Tech Tuesday. People tell you to go to Tech Tuesday to network. And I was absolutely horrified. It was after work from Nokia, and I thought, I'll just pop over. It's across the street. It'll be great. And everybody was in suits, and they were drinking, and it was very packed, and I didn't know who to talk to, what to do. I stood there eating pizza. I stood in the corner, and I didn't talk to anyone, and I ate pizza, and I was very afraid. I know that's not how you do networking, but that's what I did. Until somebody walked by, and she was like, I think you need a friend. And I was like, I desperately need a friend. And she introduced me to some people at Invest Ottawa, and I eventually met Ella. And I went to lunch with Ella, and I said, I think I want to host a hackathon. I said, I think that would be fun. That's something that I want to do with the club. And she emailed me a week later and said, we can do it. She said, Invest Ottawa will host it. You can come and you can have your hackathon. And that was another big step. I wasn't ready. I had never even been to a hackathon. I was just talking about my ideas and how I think it would be fun to do it. And she put it into action. I wanted to do interviews as prizes. I wanted companies to show up. I worked really hard. Our team worked really hard. We had 4 team members. They emailed every day. We went to meetings every day and pushed really hard to make it happen. And we did. We had 70 people attend. We had 4 companies. We're still waiting for people to do interviews. We've got some mixed feedback. Some people did call and do some interviews, and some haven't yet. We did get a good rating. So that was we also did a panel event. So we did a Women in Tech panel event. We had some CEOs, we had some leaders. We even had questions to be asked. So I was so worried that nobody was going to ask questions. So I had some pre-written questions, and I told people, like, if no one says anything, you can ask this question. But we were really lucky that I had to cut people off and tell them that it's done, because we were running out of time. There were so many questions being asked and a lot of engagement at that event. It was really nice. So this is one of our first posters ever. We just general meeting, October 1st, 2 p.m. Like, you can see the room number, and that was when one person showed up. So we've really grown from just one person. We did the Nokia, and we've got around 30 members now. So it's like 30 members on like our mailing list or contact list. So those are like the main people that we reach out to when we're hosting things. And then that's one of our more current posters going on. So now that I'm done with or passed all my classes and graduated, I have to give the club to someone else. So I've given the club away to a different leader who's taking it over. And it's her job to continue with. I'm going to stay as an advisor with the club. And so I guess the real thing that the club taught me was that I wasn't ready for 90% of the things that I did. I did not know how to host a hackathon. I didn't know how to host an event. And networking really helps. So I just talked to people and people just made it happen. And we really got a lot of opportunity. And don't quit when the room is empty. So if your professor is the only one who shows up to your meetings, like just keep going. It's okay. So that's it. I don't know if you guys have any questions for me or if we're all done, but that's what we've been doing. Yes.
So earlier you mentioned like you made really good points. Like, you know, if you're good at one thing, like that's more than like. What's your take on companies like putting in their job descriptions? Oh, you have to be back and front end, UI, UX, cloud, security, like all in one person. What's your take on that? And like just kind of contrasting it.
So the question was, I said that it's good if you're good at one thing. So you're good at back end. And then the question is, what is the take on when companies list that you have to be good at back end, front end, UX, cloud, just a one and all? And I'm not sure if you're actually going to do all of those things. So like if they listed on the posting, I feel like most jobs, I don't know, but I feel like maybe most jobs you're just not going to do all of those things, or you're going to do a few of those. I don't know how you could do everything. We had a hard time doing everything, like making one person know how to do everything was tough. Yeah.
So what's the Ada Sisterhood doing now?
Now, so the new leader is in. Summer is slow. So like at Algonquin College, the summer's pretty slow. So I think what we're going to do is really ramp up for fall. So we're going to take this summer to plan some events for fall. We've got a lot of like good connections. So we've made connections with Nokia and then past companies. So I would like to do some more networking events, panel events, and we're always looking for more, like to contribute with more people and be involved with more organizations. But we're still working on what we're going to do for fall and winter. We're going to spend the summer planning.
So given all this experience, what would you do differently?
I would take more time to plan. Some of these things need way longer to plan. Like, I don't think running a hackathon with 4 people in 3 months is enough time to get everything like from scratch. Like, we had no connections, no contacts, no anything. Like, it was just us in a room, and we were like, we had to reach out manually to everybody. Like, we didn't have like, oh, we know Joe who knows Sam who can get us into with this company. So I think events take a lot more time, and expect way less people. You have 80 people registered and like 40 are probably going to show up. So expect smaller crowds than you're anticipating.
But always order enough pizza.
Always order enough pizza. Yeah, people love take-home pizza. I'll take home a box of pizza.
Any other questions for Kira? No. Yeah.
Thank you very
Thank you very much.
Yeah, thank you.
We're just going to take a second here. Unless there are any other questions, I have a question for you. Who's not been here before? I recognize a few faces. So welcome. So how did you find us? Meetup, yes. The thing that the OWASP is taking away from us. Yes, great. Yeah. You know Kira. Awesome. So word of mouth, excellent. And word of mouth? All right, good. Thank you. other events? Okay, right, right. Yeah, I think I'd like to try to speak there again. I once spoke there about 2 years ago, so awesome. So we're running with a bit of a skeleton crew here at the moment, but we meet monthly, third Wednesday of every month, typically in this room. The only time we don't meet the third Wednesday of every month, unless it's summer and we're all on vacation, or we have a special speaker and we're trying to accommodate their schedule. But typically, we always try to be here on the third Wednesday of every month. We try to be on all the anti-social medias like Mastodon and Blue Sky. We have a Twitter account, or had one, but we don't use that anymore because I don't want to have a shower every time I post. So we don't use that. We're looking at changing Meetup because OWASP is removing Meetup because they tripled the costs and they pay for 130 chapters plus. So as a nonprofit foundation, they couldn't really afford that. So we're looking at alternatives, but we also have a GitHub account that we're trying to at least have a stable place to have information. Now, normally we would have a public service announcement slide that would have all our details like Slack channel and things like that. But if you look at the card that I've been giving out, that has an URL that will show you all our details. So enough about that. I would like to introduce our next speaker, and I will just grab my notes here so I get everything right. So Jainil is a security engineer at Nokia Canada and an April 2026 graduate of Northeastern University. He's based in Ottawa and has his OSCP Plus certification, and he serves as the Offset Canada chapter ambassador. So we have now 3 chapters in the room. We have the Ada Sisterhood, the OSCP chapter, and OWASP Ottawa. So he's also a member of the Cloud Village team and runs at DEF CON, RSAC, and other major B-Sides events. So please welcome Jainil, who's going to talk to us about malware.
Presenting. Is it visible?
I can't see that there.
You put it in for that room and share that.
Second screen.
Yeah, just we have.
There.
Good evening, everyone. Thank you for having me here. Like, this is my first solo talk, and the presentation that is going, which is today I'm going to present is Shai-Hulud, Anatomy of a Self-Replicating Worm. I have divided this presentation into two parts. Like, first I will show you the basics of malware analysis, and then I will dive deeper into Shai-Hulud. Am I audible? Like the people sitting behind? Okay, thank you. So this is bit about me, as like Garth has already introduced. Like, I am security engineer at Nokia Canada. I have just started my full-time role yesterday. Before that, before this, I have completed 3 co-op terms at Nokia Canada, 2 as an engineering lab technician and 1 as an automation engineer. I got my OSCP last year, and then I become OPSEC Canada chapter ambassador. I'm also a team member at Cloud Village, which serves at major conferences like DEF CON, RSA, B-Sides, and more. And last month, I have completed my graduation from Northeastern University, Toronto campus. So this attack has compromised around 500 plus packages, the Shai-Hulud, that was used by thousands of developers and downloaded millions of times. It is self-replicating worm and 0 clicks were required. We will dive deeper into this later on. Our today's path is, first, I will start with the foundations, like what the malware analysis is. If someone is new in this cybersecurity field, or someone just want to start learning like how to do malware analysis, then this R is for you. Then I will move on to the static analysis, followed by detection with YARA, dynamic analysis, and the last inside Shai-Hulud. What is malware analysis? Now let's understand what malware actually is. Malware is something, a malicious software which has purpose, which has only malicious purpose. There are different types of malwares like worms, virus, trojans, rootkits, botnets, and more. The analysis of this malicious software is known as malware analysis. There are 2 types of malware analysis. Today we are going to cover over here. Like, this is the basics. This is not actually, there are lots more than this. The first one is static analysis, and the second one is dynamic analysis. The static analysis is what we got to know from the malware without running it. And in the dynamic analysis, we will actually run the malware to see its intended behavior. The static analysis has its own pros and cons. Like, it's safe, file is never executed, but it is fast and repeatable, and it catches the packers, imports strings, and more. But it also has its cons, like it misses runtime behavior, obfuscation, hides original intent, and encrypted string stays encrypted. So we will not get this information by doing the static analysis. So we will need to do something to see its actual behavior, and we can learn that from the dynamic analysis of the malware. The dynamic analysis is where we run the malware in a safe, isolated environment, where we learn its true behavior. We captures network, file, registry, whatever that malware is doing. We run this malware in a safe, isolated environment. So like, we should not try running this in a host computer machine. The strings get decrypted at the runtime in the dynamic analysis, and it has also its cons, like lab setup and discipline required. And sometimes the modern malwares are anti-VM, where the malware will not perform its actual behavior inside the VM. And some samples are refused to run inside the VMware. Before we touch any sample, like there are 5 rules that we should follow. The first one is that we should use an isolated VM so that we do not infect our own host machine. The second one is the network of that isolated VM is host only, so that it do not contact with the external internet. And there should be no shared folders, like no drag and drop, no clipboard sharing with the host. So you do not run that malware accidentally in the host machine. And after setting up the malware, you should take a screenshot first, and followed by like analyzing the malware, and then again reverting that to back to its original state. And while doing this analysis, we should document each and everything: the hashes, screenshot, timestamp, memory. Memory is not a tool over here. Sorry. These are some of the tools that can be useful while doing the analysis, but this is not limited to. There are lots more available in the market. There's a Flare VM that is developed by Mandiant, which can be very helpful while doing the malware analysis. All these tools are present in that VM. So the first one is for doing the static analysis is file and string. These two tools are command line utilities which can be helpful to know what the file is and what strings are present inside that file. Then there's PBear, CFF Explorer, PE file, which helps us digging deep inside the file. There's the Ghidra as well. This is developed by NSA and it's an open source tool. In dynamic analysis, Process Hacker and Procmon can help us viewing the Windows executable file. Then there's Wireshark, which can help us for sniffing the network. And these are some of the online sandbox which can help us if we do not want to set up the malware analysis lab locally. I will show you one small demo at the end of this sandbox, how this tool can help us. Now, what actually static analysis is? As the name suggests, that reading malware without running it. So first one, it starts like identifying the file, like what the file type is. The file can be .pdf, .png, .mp3, anything. But inside that file, it actually can be, it has a different purpose. For example, it can be an exe file, which we can know while seeing the file, like while analyzing the file using these tools. For example, this sample.bin, while running against this file tool, can shows that it is a 32-bit architecture exe file and having a subsystem GUI app. We can also see the compile time, but it is easily fakeable. Like it's not the one that shows over here. Like malware developers can easily fake this one. The hashing and reputation. Like if we run these files against any of the hashing algorithms like MD5, SHA-256, SHA-1, then we can get a string which we can then upload into tools like VirusTotal, Malware Bazaar to check if anyone has detected this malware before. VirusTotal is maintained by Google currently. It was originally developed by a security researcher, which is now taken over by Google. Malware Bazaar is a database of malware samples. Strings. This tool can help us to analyze like what is inside the malware. Without running it, we can get information about the text fragments that are present inside the file. And by that, we can analyze like what it is trying to do. Over here, as we can see in the example, like there are few of the strings that we got from this using this tool from this file, and we can analyze and see that this malware is trying to connect a command and control server, and it is establishing a persistence in Windows registry and loading of following DLL files. There are two APIs as well. The second one is trying to connect with the HTTP web request, and the first one has its, wait a minute. The first one is trying to write a registry value. So we can get a lot of information while analyzing the strings that are present inside the malware without running it. The PE file format. This is the file format that is specifically for Windows. The DOS header, which is present in all the Windows file nowadays, this header is given in all the Windows binary so that the operating system of the DOS is outdated now. But if someone tries to run a new Windows file in that old operating system, it gives a message like you cannot run this program in this old operating system. It's a simple message. It helps in like crashing in say like sorry. The DOS header starts with two letters M and Z that you will see in every Windows binary. That's the legacy from the 1980s and it's still there. Then the PE header, which tells you the architecture, timestamp, and the file characteristics. Then the optional header, which is anything but optional. It tells you where the program starts executing, what address it loads at, and what kind of program it is. Then the section table, which is a map of where each section lives in the file, and finally the section themselves. Text holds the code, RData holds read-only data like strings, data holds variable, and RC holds resources like icons and embedded file. Why do we care for this? Because these headers reveal everything, which API the program imports, which function it exports, what's embedded inside it, whether it's digitally signed, and whether the section names look weird, all without running it. This might be the single most powerful technique in static analysis. Every Windows program declares a list of functions it needs to borrow from the operating system. That list is called the import table, and the import table is essentially the malware's shopping list, what it plans to do. Look at this example from kernel 32. It imports create remote thread, write process memory, and virtual alloc. Those three together are the textbook recipe for process injection. Taking your code and showing it inside another program memory so it runs under program's identity. From add WAPI 32, reg set value, and reg create key, registry writes, which means persistence. From win inet, that's how you make HTTP calls, meaning command and control. So the malware hasn't run yet, but its shopping list tells us, I'm going to inject the code into process memory. I'm going to write the registry to survive reboots, and I'm going to phone home over HTTP. Last step in static analysis is entropy. Entropy is a measurement of randomness. On a scale from 0 to 8, normal code, normal text, that's around 4 or 5. Compressed or encrypted data, that's 7 and above. Why does this matter? Because malware author often packs their malware. Packing means they take the real code, they compress it or encrypt it, and they wrap it in a small unpacking stub. When the program runs, the stub unpacks the real code into memory and jumps to it. So when you look at the file on disk, all you will see is jumbled mess, high entropy. So what we know without running it? Without running the file, we got following information, like it's a 32-bit Windows GUI executable. It calls out to malicious command and control server. It writes the registry key, run key for persistence, and it uses API consistent with process injection. It launches PowerShell with encoded arguments. So this is the information that we get from doing the static analysis of the malware. Detection with YARA. Like, what is YARA? YARA is a pattern matching for malware. It's a language for writing rules that say if a file contains these strings and looks like this, call it malware family X. Antivirus EDR uses YARA. Threat hunters across the industry use YARA. 3 reasons it matters. It is precise. You can write very specific rules with very few false positives. Way better than just matching file on hashes. It's shareable. YARA rules are plain text. You can write one, paste it in a tweet, and someone across the world can use it. And it's fast. YARA can scan gigabytes of files per second on normal laptop. Like, this is how a YARA rule is written. It's in simple text format. Like, here you can see that the metadata shows the author, the description, and date about the rule. The strings, these are the strings that we got from the malware while doing the static analysis. And there's a condition that if any of these 2 strings are present in the malware, then detect it, calling it as a sample family 2025. Now let's move on to the dynamic analysis. At the end of this section, I will show one short demo. Why we still run it if we have already done the static analysis? 4 reasons. First, decrypted string. Many samples decrypt their C2 server address only at the runtime. Static won't see them, dynamic will. Second, the real process tree. When malware runs, it spawns child processes, maybe PowerShell, maybe CMD, maybe a fake SVC host. Watching that tree form in real time tells you the order of the operations. Third, real network traffic. You see exactly which IPs and domains it tries to contact, in what order, with what payloads. And the fourth one is persistence in action. You watch it write that run key, you watch it create that scheduled task in real time. Static analysis tells us what it can do, but dynamic shows us what it actually does. So the malware fights back. The malwares are not that easy, like when doing the analysis. If the malware detects that it is a VM, then some of the malwares might not run. This is how it is designed by the attacker. Then there's a sleep and stall. Some of the malwares is configured in a way that it sleeps for some particular amount of time before doing anything to outlast sandbox runs. The sandbox, which are available online, gives only particular amount of time to analyze the malware for free. Then actually we need to pay some amount of money to use it. There's a debugger check. If debugger is present, then again it will not run. And these are some of the things that like the attacker keeps in mind while developing a malware. Mouse activity and geofencing. some of the malwares run in only particular countries having particular languages, while it do not run in others. So when we run a malware inside an isolated VM, we actually get to know like what process and functions it is calling, what threads it is creating. Like this is an example of the tree. Yeah. So what does it talk to? Like malware talk back to its C2 server. After some of the malwares are configured in a way that it talk back to the C2 server for extracting data or credentials or any information it requires. What does it leave behind? After the infection, malware needs to persist. It needs to survive a reboot. Windows offer a lot of places to hide that. 5 of the most common run keys, registry keys that actually launch program at login, schedule task, created with sh task command, run on a timer or at events. Startup folder drops a shortcut here. It launches when the user logs in. Services, install yourself as a Windows service and you run the system privileges every boot. And WMI subscription. This one's stealthier. You can register an event filter and a consumer, and Windows trigger your malware on a certain system events. Why do we actually care about this thing? Because if you find a malware on a system but you do not find the persistence, you haven't cleaned that malware. It will come back at the next reboot. So the part of dynamic analysis is wait, watch, and catalog every persistence mechanism it sets up. So these are the few tools that are available online which we can use to analyze the malware dynamically if we do not have any lab setup in our local environment. There is AnyRun, Joy Sandbox, Hybrid Analysis by CrowdStrike, and the fourth one is Triage. Okay, so now let's move on towards the Shai-Hulud. I will show the demo at the end of this presentation. What is Shai-Hulud actually? It is a supply chain attack that has, as I told before, that has infected over 500 plus NPM packages, and it doesn't stop yet. Like 2 days ago, officially, there's a fourth wave of this attack has been discovered. Yeah. The attackers have named themselves this worm as a Shai-Hulud. It is self-replicating worm, and I will show you in the upcoming slide like how it actually works. The timeline of the escalation is in September 2025. It was the first official report was published by a security researcher, and which shows that 500 plus packages were compromised. Later on, Cyber Security and Infrastructure Security Agency of US have issued an alert on this one. In November 2025 and December 2025, Aikido's security researcher have published another reports on this attack. The worm has been evolved in the following attacks. Like there was Viper functionality added. It actually deletes all the data on the developer's laptop or computer. And in the third wave, heavier obfuscation was done to avoid the detection. Why NPM makes this possible? You install one package, and each install runs some script. The trust is transitive over here. The trust is transitive over here, so the machine do not scans the packages, and it directly gets installed. This is the most dangerous line in package.json, that at the end of all the packets are installing, like if a particular package is getting installed, then at the end of that installation, one line is running post install, and in that it is running node bundle.js. In that bundle.js, all the malicious content was present. And what that bundle.js was actually doing, it is discovering all the credentials, tokens, and keys that are present on the developers or particular user's computer, and then that all that keys are pushed to the public GitHub repository. And then if it is on a developer's laptop, then if that developer is maintaining any other npm package, then it replicates the same thing in other package and push that package into the npm repository, inject itself into other packages the developer maintains, and publish the newly infected version to npm. So this is how it was replicating itself. So these are the few things that malware was actually harvesting. It is a type of a malware, self-replicating worm. AWS, GCP, Azure keys, GitHub tokens, npm tokens, and other secrets, whichever that worm finds on the developer's machine. And then it exfiltrates all the data in a public GitHub repository. You can see over here, like many repositories were found online with all these details, like AWS GitHub keys openly. And anyone can find this, including the next attacker. And how does it replicate itself? It steals the npm token that a developer of the developer account, list all the packages that is developed by that particular software developer that developer maintains, inject bundle.js into another file, and then publish that to the npm. The next victim who is running npm install, he or she will also get affected. So this is how it has evolved. Version 1, September 2025, the initial discovery, bundle.js as a node.js worm, targeted mainly Linux and Mac OS where developers tend to work. Version 2, November 25, the second coming, 27,000 exfiltration repos. They switch runtimes. Instead of running on Node, they used Bun, which is a newer JavaScript runtime, specifically to evade tools that were monitoring for node activity. And they added a wiper that would destroy all the files that are present on that machine. Version 3, heavier obfuscation found in that V8 Money React Big Calendar package, more reliable persistence, same campaign, but it's evolving. And the fourth one, as I said, which is not present in my presentation, but it has been discovered recently, which you can find online. What does Shai-Hulud actually extracts? It extracts exactly the same credentials a malware analyst machine has: GitHub, public access tokens, npm tokens, and all these keys, as I mentioned before. Public IOCs from Unit 32, Datadog, reversing labs, and ways are enough to teach this. Sometimes the right move is not to run that package. Now, what we can do to get saved from this attack? For developers, use log files, pin your versions. When you can install with the ignore scripts flag, with disable the post install scripts. which I showed before, that runs bundle.js. Enable two-factor authentication on NPM and GitHub. Audit dependencies before you add them, at least the top level ones. For organizations, maintain an internal allow list of approved NPM packages. Monitor for unusual GitHub repositories. And scan packages with tools like Socket, Sync, or reversing lab spectrum. Write EDR rules that flag suspicious post-install behavior. And for everyone, if you suspect exposure, rotate your credentials immediately. Search GitHub for Shai-Hulud repos using your username. Subscribe to the CISA and vendor IOC feed so you hear about the next wave on day one. And the mindset shift: assume compromise, verify first, and then trust. Now what's next? Like, I have show some of the basics of the malware analysis to all of you here today. But if you want to go deeper in this is the following things you can do, like learn JS deobfuscation, reverse engineering, anti-analysis evasion, building a sandbox, and certification and courses. In the next slide, I have presented some of the resources as well, which can be helpful in learning all this. If someone wants to take a picture.
Would you be okay if we share the slides?
Sure.
We can share the slides.
And these are the resources that can be helpful in learning. For setting up the VM locally, I would say just install the Windows and install Flare VM installation script that is available online, which can be helpful to install all the required tools. And how AI has changed malware analysis. Like, before we used to do all these things manually. Now, after analyzing the malware statically, we can simply feed all the screenshots directly to the cloud, and it can give us meaningful observations. But these models do hallucinate, so we will always need to verify that. For analyst, we can easily create YARA rules now using this AI. It auto summarizes samples and IOCs for us, decompile and explain us via Ghidra MCP. Like it can be directly connected to the any of the AI which is available online. And for attackers, AI generated phishing and lures, like it can easily lure the people. And LLM obfuscated scripts, as we've seen in the Shai-Hulud 3.0, and also autonomous offensive agents like Expo that can help the attackers. And the new normal, the triage time has been dropped from hours to minutes now. Detection lag is the new attack surface. And as I said before, models do hallucinate, so we will always need to verify that. Fundamentals still beat any assistant. Thank you. Thank you, everyone. But it can be very much possible with the Python as well. No, it's not possible. So we will always need to verify the packages, but it is useful, so all the developers will use. Yeah. Thank you.
Question, another question? I'll just repeat the question while I'll just repeat the question so people online can hear. So the question is, if the malware is using techniques to sense whether it's being analyzed, and you try to bypass that, what techniques can you use to try to stop it from bypassing that avoidance?
So sometimes the malware itself do not run in the isolated environment, but we can create a similar environment which is not VM, like not a virtual machine, but an actual environment, but it is isolated so that other systems do not get infected.
Like this computer right here that now does not talk to the internet.
And in some cases, malware will need to connect with the internet to perform its intended behavior. Without that, it will not run. So in that case, there are some of the tools like FakeNet that I have mentioned. You can use those tools where it actually mimics the internet behavior, but it is not actually connected with the internet.
Next question.
Now that you work for a company, like we talk about how your company protects from attack vectors, threats like Shai-Hulud.
No, I cannot discuss on that.
So I'll just repeat the question for the internet. The question was, now that Jainil is working for a large company, what tech can he expand on the techniques that they use to analyze malware? And the answer is, I can neither confirm nor deny that.
So I can say that views expressed here are strictly my own. I do not represent any organization today. Everything that follows is from me on my own time with my opinions. Thank you.
Any other questions?
Like this, current package.json, maybe if you installed some.
I do not get your question.
No, I didn't get the question either.
Do you have in mind any packages that we can use? Analyze the package.json, all the packages that we have installed, and maybe tell you like, oh, it's
So scanner.
yeah.
Yeah.
Yeah, there are. I mentioned some of the tools in my slide as well. I can share the slides, which can be, those tools can be helpful in like analyzing the npm packages that are present in the software. Yeah.
Any other questions? Are there any questions online? So I just have one question. You had the one slide on AI analysis and attackers using AI. Who do you think has the advantage right now?
It has advantage for both the attackers and the analyst as well. So there's a company called Armadine. The Mandian founder has developed that company. Currently, they are working on completely building autonomous agents. That agents will do it will perform the whole kill chain on its own. So this is something really dangerous for the, while it is constructive as well, like we can get to know all the loopholes in the network. So it's both like constructive as well as destructive.
Right. And I just had another question while you were saying that, but then it just escaped me, but maybe I'll catch you later.
Okay.
Anyways, thank you very much for sharing this. Oh, now I remember the question. Has there been attribution for Shai-Hulud yet? Attribution, like, do we know who did it? Is there an APT that's known?
APT, I didn't like dig deeper on that, but we can find that information.
Okay. All right. Thank you very much. So that's it for May. Sorry about the technical sort of janky issues we were having with that one machine. But now there's an echo. Third Wednesday of every month, in case you hadn't heard me say this before, this is OWASP 25th anniversary. And yes, 25 years and we're still fixing the same dumb crap. But so what they decided to do, the OWASP, the International Foundation, said we'll choose 11 chapters. Why not 12? It's a full year, right? No, they chose 11 because they thought of this in January. We'll choose 11 chapters internationally out of the 130 plus chapters internationally to have a party. And OWASP Ottawa got selected. So in October, we're going to do something. We're going to have a day. We're going to have it in this room and maybe other rooms. We're trying to organize something. Maybe it'll be workshops. Maybe we'll have a CTF. We'll probably have a speakers track. And we'll probably have a party afterwards. And OWASP is going to, foot the bill. So stay tuned for that. If you want to speak at one of our events, please let us know. We'd love to hear what you're up to. We'd love to hear what you've got down on the slab. And we'll see you next month. Thank you.